Hello and welcome to NPC Academy, where we turn NPCs into graduates. With our first lesson, we're going to be teaching you how to complete the square. So what even is completing the square? That's when we've got something of the form of a quadratic. So maybe 3x squared plus 9x take 3 is equal to 0, right? And we want to turn this into the form of x take a number, so we'll call it d, all squared is equal to a number b. So let's get a random example. What does this look like in real life? So that would equal something like x take 3 squared is equal to 4, maybe. And now we get it in this form so we can find a solution really easily. That's why we complete the square. I'll show you how easy it is. It takes 2 seconds. All you have to do is square root both sides. So you get x take 3 is equal to plus take 2. And then you plus 3 on both sides, and you get 3 plus take 2. Therefore, x is equal to 5 or 1. Right, pretty easy. So, now that we know why it's important, cool, it's not useless, we will figure out how do we actually do this. Alright, so first things first, get out of here. Why? I don't want this, it's in the way. Alright, now first things first, we gotta divide everything by 3 because we need this coefficient here for x squared to equal 1. So we do x squared plus 3x take 1 is equal to 0. So remember back here we've got this form, right? If we did not make the coefficient equal to 1 over here, then we would actually have to add an a inside of here because we need another unknown variable to get the coefficient of x squared. But if we divide everything at the start so that the coefficient we know is equal to 1, then we can just replace that with 1 times x, which we just delete, and it's like this, right? Pretty easy. So that's why we divide at the start. Next, we take away all the constants and put it on the other side. So transform this to x squared plus 3x is equal to 1, okay? And now we add a constant to each side. So we go x squared plus 3x plus c is equal to 1 plus c, where c is just any constant. So why do we do this? Okay, in case you don't, I'll warn you now, this is a lot of substituting, but it's pretty easy. Once you get the hang of it, you go through it once, it's actually not bad. So we'll do a tiny proof, it's super easy, trust me. We're not NPCs here, we're gonna graduate, stay with me. So we've got x take d squared is equal to b, okay? That was pretty simple. Now we know this can be rewritten as x take d be rewritten. So we know this can be rewritten like so. And now we just have to cross multiply and expand it. So we go x squared take 2dx plus d squared is equal to b. And now, if you notice above, on our left-hand side, we have no constant. Because what we want to do is we want to transform this whole thing here that we started with into this whole square here. That's why. So then we can do what we did earlier. So the yellows want to be yellows. But the problem is, once we expand it, which we did down here, you find you need a constant, which is our d's, right? Our d is the constant. But what happens if we don't have a constant, like above here? Then if we let d equal 0, then we get x squared by itself. X squared takes 0 plus 0, which is equal to x squared. And the problem with that is we've got no x term by itself. We've only got an x squared term. So the problem with that is we've got a 3x here, but if we let d equal 0, then that means we can't have this 3x term. So we'd have to delete that, and it doesn't work. So to fix that, we need to add a constant. And that's what we've done here with our plus c. We've just plussed c to everything, which is our constant. So now that we plus c to both sides, we want to turn x squared plus 3x plus c into our perfect square, right? X take d squared That's what our main goal is. So now that we x take d squared, right? Now, remember above, we just found what x take d all squared is. We did the proof, right? We found it goes to this, it goes to this, it goes to this. So we can actually so we can actually do substitution to change this. So we can rewrite it as this. So now we can rewrite x squared plus 3x plus c is equal to x squared take 2dx plus d squared. Okay, interesting. So now we can compare each x term with each other, because what we're saying here is we want the left hand side to equal the right hand side. That's our goal here. So to do that, we need each term to equal each other, right? If two things are equal, then everything has to equal. Pretty simple. So x squared is equal to x squared. That's good. Let's try the others. 3x is equal to negative 2dx. And then c is equal to d squared. All I did was just get each term like so. And now we're going to do some basic maths. So now we're going to solve this by going divide by x, so you get 3 is equal to negative 2d, and then divide by negative 2 on both sides, and you get 3 over 2 is equal to d. That's what our d is. And now over here, because we already found our d just now, we can substitute that in to find c. So we can go c is equal to negative 3 over 2 all squared, and that's equal to 9 over 4. Coolio. Now we can go back down here, we go x squared plus yeah, what?
Okay, thank you.
I don't want to help. Okay, so now we found what our unknown variables are. We've got our d and we've got our c. Happy days. And now we can do some substitutions. Again, this should be our last ones. So let's go above to our original equation of x squared plus 3x plus c. X squared plus 3x plus c is equal to 1 plus c. Now, we know that x squared plus 3x plus c is equal to x squared take 2dx plus d squared, right? As we did over here. So we're going to substitute that part in. Take 2dx plus d squared. And we know this is the formula for the perfect square. So now we can do another substitution. X take d squared is equal to 1 plus c. And now we just sub in our numbers and we're done. So we go x take negative 3 over 2 squared is equal to 1 plus 9 over 4. So x plus 3 over 2 is equal to 13 over 4. Now, that might have been a bit confusing with all the proofs, so we'll do one more, but this time I'm just going to do the method by itself and we won't do any proofs, and I'll show you how easy it actually is. So let's go with something of 2x squared plus 5x take 4 is equal to 0. So we're going to divide everything by 2. So we go x squared plus 5 over 2x take 2 equal to 0. And now we're going to put all the numbers on one side and the x's on the other. So x squared plus 5 over 2x is equal to 2. And now we're going to plus that constant to each side. So x squared plus 5 over 2x plus c is equal to 2 plus c. Now we're going to make our perfect square. So we're going to write down the formula x take d all squared is equal to x squared take 2dx plus d squared. And now we're going to make our x squared plus 5 over 2x plus c equal to our perfect square, because this is what we're trying to turn it into. And then you write x squared plus 5 over 2x plus c is equal to x squared take 2dx plus d. Now we do our equating the terms. We get 5 over 2x is equal to negative 2dx, and we get c is equal to d squared. Forgot to write that. Then you find what these two things are. Now that we found our variables, we go back and write the original equation. So x squared plus 5 over 2x plus c is equal to 2 plus c. And now because we made this into our perfect square, we can go x take d squared is equal to our 2 plus c. And we substitute in the values, so we get x take negative 5 over 4 squared is equal to 2 plus 25 over 16. Now we get x plus 5 over 4 squared is equal to 32 over 16 plus 25 over 16. And therefore x plus 5 over 4 squared is equal to 57. There we go. That's how you complete the square. And there we go. That's how you complete the square. Hopefully that made sense. If not, let me know down in the comments. I'll see you in the next NPC video.